Hello everyone, my name is Tanmay. Right now I'm studying in BITS Pilani. I finished my first year of engineering. I gave JEE Mains and Advanced last year in 2025 and I had secured 99.77 percentile in JEE Mains. Now I'm going to be attempting to solve all of this year's JEE Mains differential equation questions. There were in total 20 questions asked. So it is a high weighted chapter. Expect minimum one question per shift from this chapter. Personally, I believe that it's a high scoring chapter because you only have three kinds of differential equations question which they can ask you, and the level of integration required for this chapter is not much compared to other chapters like integration itself, you know. So even if you're average or a bit above average in integration and have a good grip on the three types of differential equations which you will encounter, I think you will easily solve all the questions at JEE Mains level. So let's begin. Let's see if I still have it in me after 1 year. All right, guys, here's the first question. Let y equal to y of x be the solution of the differential equation. And then here we have the equation as given. All right, so here, first of all, as you can observe, we have dy and dx both are separated. So our first course of action has to be to link dy and dx together because as you observed, in all three cases of differential equation, dy by dx is always there, right? You won't have dy and dx both separately. So I need to simplify dy by dx, and then dy by dx has to be individual, right? Here we have this x into root of 1 minus x square, right? So this has to be separated from dy by dx. So I'll simplify it to y by x equals to cos inverse x divided by root of 1 minus x square, right? After simplification, we get this. Now integrating factor. Okay, wait, before this is a linear differential equation, right? You agree with this? Yes. Since it is a linear differential equation, in general, okay, I'll state this only once because it's important. P of x into y is equal to q of x. Okay, so how do you know it is an LDE? Because we have a isolated individual y here, right? I'll show you. We have this individual y here. Okay, it's not y square or y cube, just individual y, and we have a equation with all the other terms involving x only. This means that it is a linear differential equation of this form. The solution is, first we have an integrating factor, which is e power integral p of x dx. Okay, solution is integrating factor into y is equal to integral of integrating factor into q of x dx. Okay, this is the ultimate solution. Okay, usually in JEE Mains, solving for the integrating factor is quite easy. Okay, but then solving this integral on the RHS is usually quite hard. Okay, so as you can observe here, what is the integrating factor? I'm solving only this question in depth. Remaining all questions on LDE, I'm solving it much faster. E power 1 integral of 1 by x dx, which is e power ln x, which is x, right? So what is the solution? Xy is equal to integral of x. What is q? Q is this part, right? So you get cos inverse x divided by root of 1 minus x square dx. Now, how do you solve this question? This integral is a bit tricky, but you have a pretty straightforward substitution here. What if you substitute u is equal to cos inverse x? In that process, du is equal to minus 1 by root of 1 by x square, which we have right here if you observe. Okay, and then what is x? X equals cos u. Okay, so I'll make this substitution cos u. Now, in the exam, how do you realize that this is the way to go? Well, you have cos inverse x, and derivative of cos inverse x is minus 1 by root of 1 minus x square. Okay, so all this links up together to be this way, and I'm sure you must have encountered this in your in other PYQs as well. So u cos u du with a negative sign, right? Now, how do you solve further? This is straightforward integration by parts, IBP, right? So what do I get? U sine u minus integral sine u du. Yes, look at me. Focus on me here. Okay. U sine u plus cos u plus c. Now, resubstituting back, what is sine u? When we have x equals cos u, we know that sine is root of 1 minus cos square. So, cos u is, sorry, my bad. Sine u would be root of 1 minus cos square u, 1 minus x square. Okay. So, xy equals to cos inverse x root of 1 minus x square plus x plus c. Right. Now, how do we find out the value of c? Well, very easy. It's given here that we have this fact given to us. Here, limit won't really matter because we have just x and like we have all simple functions here. So it won't really matter left hand limit or right hand limit. So I can just assume this to be y of 1 equals to 1. Substituting x to be 1 and y to be 1, we get c equals to 2. Okay, no shortcut here, just substitute and then solve for c. Okay, now they want y at x equal 1 by 2. Once again, just substitute x equals to 1 by 2, you get 3 minus pi by root 3. Therefore, answer is option A. Okay, it took me 3 minutes 14 seconds to solve this. Fine. Now, in the exam, how would you approach this? First of all, in the exam, I would say that dy and dx are separate. So bring dx here, and then I would see that we have an individual y here. Okay, so dy by dx plus some individual y present. This means that it's an LDE for sure. No other case. Okay, if you have an LDE, what is the integrating factor? If you observe here, integrating factor would be just x because we have y by x here, right? In this equation, simplified equation, we have y by x, right? The coefficient of y is 1 by x. So automatically if becomes x. Okay. So in the exam, I would just directly reach this stage. I would not do any working beforehand on the paper, and all the previous steps I would just do it mentally. With enough practice, even you will reach there. Okay. And then after this step, it becomes slightly tricky if you are not experienced with integration. But then I saw that we have cos inverse x and then its derivative right here. So make the substitution, we get integral of u cos u. This is a fairly easy integral which all of you might have encountered before. Integration by parts, do it as fast as possible, and you will reach this step. After that, it might be an unpopular opinion, but I feel that solving till this step, actually takes less time compared to how much time it takes after that, finding out value of c and finding out the value of y at x equal to 1 by 2, because it's just pure substitution and just mental math. How fast you can calculate. So after that, just substituting and mental math, calculate as fast as you can, and don't make any mistake here, because you might have solved all the way until this step, but then if you end up making a mistake in substitution, which is supposed to be the easiest part, it's a waste, right? So honestly, not making a mistake here is the most important part of this question. Fine. And then just get the answer. Not that hard of a question. So moving on. All right, guys. Next question number 2. Let y equal to y by x be the solution of the differential equation, and then we have an equation here. Once again, dy and dx are separate. So after simplification, what equation do I get? Y by x equals to 1 by x minus root of x square minus 1. Okay, simple enough. Now this is a linear differential equation. Integrating factor is once again x, same as the previous question. So solution is xy is equal to integral x by x minus root of x square minus 1 dx. Fine. Now, the most general course of action for these kind of weird looking integrals is to rationalize the denominator. Okay. So how do I do that? Well, multiply by x plus root of x square minus 1 on numerator and denominator. So what do I get? X plus root of x square minus 1 dx. Now solving the first part of this integral is just very easy. Integral of x square dx, x cubed by 3 plus integral x root of x square minus 1 dx. Now this integral looks weird and abnormal, but trust me, pause the video and think about it. Think of one commonly encountered substitution for these kind of weird integrals, especially whenever you have this, square root of x square minus 1, these kind of terms in the integration, what do? You might have encountered these questions before. Okay, here's the way. X equals to secant theta. Why? Secant square theta minus 1 equals tan square theta. Square root is equal to tan theta, right? So it becomes much more easier to solve. In general, if you ever encounter square root of 1 minus x square or x square minus 1 or something of that sort, square root x square minus a square, something where a is any real number, always remember trigonometric substitutions are the way to go. Okay, they will genuinely make your life much more easier. So we get secant theta tan theta dx is once again secant theta tan theta d theta, right? Now how do you proceed? Here we have tan square theta secant square theta, right? What if I substitute t is equal to tan theta? What do I get? T square, because tan square theta, and then you have secant square theta d theta, but dt is just secant square theta d theta, so dt, right? So x cube by 3 plus tan theta whole cube by 3 plus c. Now what is the value of tan theta? It is nothing but square root of x square minus 1 equals tan theta, right? Right? So x square minus 1 whole power 3 by 2 divided by 3 plus c equal, this is the solution of the equation. All right, simple and easy till now. Now given that y of 1 equals to 1, substitute, you will see that c equals to 2 by 3. Okay, so y of root 5. Okay, now the actual value of y of root 5, which you will have to solve in the exam, only after that can you find out the gif of that greatest integer value. So y of root 5 is 5 plus 2 root 5 by 3, right? Now what is the greatest integer value of this? Now we know that root 5 lies between 2 and 3. Okay, most JEE aspirants know that root 5 is approximately equal to 2.23. Just substitute, you will see that greatest integer value comes out to be 3. Okay, if you don't know, if you don't have an idea about this, even if you substitute root 5 as 2, okay, root 5 as 2, you will get 9 by 3. This is equal to 3. If root 5 is equal to 3, you will get 11 by 3. In both cases, greatest integer value is still 3. Okay, so it's a no-brainer here. So answer has to be 3. It took me 3 minutes 23 seconds to solve this question. Okay, fine. Now in the exam, once again, I would observe that it's an LD clearly. We have a isolated y here. This means that I would directly solve at this step. I would do all the previous steps in my mind. I would arrive here at this integral, rationalize, come to this part, and I would arrive at this step then directly. Okay, in the exam, minimizing the number of steps which you solve on paper is the best method. Okay, as much as you can solve in the mind. Okay, I will reach this integral. This would be a bit tricky, and I would spend some time thinking on how to proceed, and then I would make this substitution, solve further, arrive here. Okay, get the value of c. Even this part is fairly easy. Finding out the value of y at x equal to root 5 is a bit tricky, and it would take me more time than expected, and ultimately I would arrive at this point. So this was the hard part, honestly, finding out this value in the exam, because under immense pressure and all that. So high chances are there that most people might make a mistake here, and in spite of solving all of this, the final answer will be wrong. So yeah, and I will get the value to be 3. Okay, so moving on to the next question. All right guys, third question here. Let y equal to y by x be the solution of the differential equation, and then we have the equation given here. Once again, it is a linear differential equation, and after simplifying we get dy by dx plus tan x into y is equal to secant cube x divided by root tan x. Okay, integrating factor is e power integral tan x dx, which is e power log of secant x equal to secant x. Fine. Solution is equal to secant x y is equal to integral secant. So here we have 1 secant x here and secant cube here. So on multiplication becomes secant power 4. Okay, secant x multiplied by secant cube x divided by root of tan x dx. Now, how do you solve this question? Okay, think for a while. It's very obvious. Okay, here we have tan x here, and here we have secant square x multiplied by itself. Okay, since we have tan x and secant square x, the obvious substitution is u is equal to tan x, because du is equal to secant square x dx, and secant square x is available to us. The other secant square x can be expressed as 1 plus u square, right? So we have secant x y is equal to 1 plus u square. This is secant square x. The other secant square x is used up here, du divided by root of u. Simple enough. Now, how do you solve further? 1 by root u plus u power 3 by 2 du. Right, this is equal to 2 root u plus 2 by 5 u power 5 by 2 plus c secant x y. So the solution is this equation, what we have right here, tan x whole power 5 by 2 plus c. Fine. Now all you have to do is just find the value of c. Given that we have this given here, okay, it might look pretty ugly and solving it is even more ugly, but you have no option. On substitution, we get c equal to 0. Okay. Next, we want y at x equal to pi by 3. On substitution, x equals to pi by 3. This is equal to 4 by 5 into 2 into 3 power 1 by 4. Okay. Therefore, the value of alpha is equal to 2 into 3 power 1 by 4. Alpha power 4 is 48. Okay. That is the solution, 48. It took me 3 minutes 30 seconds to solve this question. And in the exam, all you have to do is just observe that it's an LDE. Come to this step of solution, okay, and then make the appropriate substitution. This time the integral here is actually not that hard. Finding out which substitution to make is not very difficult, because you only have one possible way of solving it, and then just keep solving. Okay, after that is just after this step is just mental math and calculation. So it's a bit tedious but not that difficult. The fourth question we have here, let y equal to y by x be the solution of the equation, and we have this equation given here, which we have to solve first. Okay, first of all, I'll simplify this, and since we have dy and dx both separate, bring them together. Okay, here we have sine of y by x. Okay, and now I'll send x here on the LHS to the RHS. Okay, y you'll see in a minute. Sine of y by x minus 1, right? This is the equation as you can see here. So if you observe, the only variable we have is y by x, right? Nowhere do you have an individual y or an individual x. You only have y divided by x in both the LHS and RHS. This means that it is a homogeneous differential equation. Finally, we have seen a different type of equation which has a different strategy of how to solve it, right? Think about it. How to solve this question? Pause for a moment, think. Focus on me here. Focus on me. I know that we have the World Cup going on, football and all that, which might be very tempting, but focus on me. Watch this video, then do whatever you want to. Okay. Now, how do you solve this equation? We make the assumption that y is equal to ux, where u is also a variable. Dy by dx is equal to u plus x du by dx, chain rule. Okay, so I'll make that substitution here, u plus x du by dx. Basically I am eliminating y here, and converting this equation into an equation which has x and u as a variable in place of x and y. Okay, into sine u equals to u sine u minus 1. Simple as that. Now, in the LHS and RHS, we have one term of u sine u, which will be cancelled, thereby simplifying it much more. X sine u du by dx equals to minus 1. Now solving this part is very easy. So we get minus cos u on the LHS after integrating and minus log x. So we get log x equals to cos. What is u? What is u? U is equal to y by x. Y by x plus c. This is the differential equation solution. Fine. Simple and easy till here. Honestly, not that hard. A very easy question which they have given here. Hence, we have much more. Okay, hence we have all this remaining. My bad. So y of 1 equals to pi by 2. This means that c is equal to 0 on substitution. Now they have asked alpha is equal to cos of this. Okay. So alpha is equal to cos of y of e power 12 divided by e power 12. This is nothing but log of e power 12, as you can see from the equation which we have got, equal to 12. Okay, this is alpha. Fine. Now we want number of integral values of p for which the equation of circle represents a circle of radius r less than or equal to 6. Okay, integral values, keep note, less than equal to 6. Fine. Now what is the radius of this circle? Radius is going to equal to square root of 2p square minus alpha minus 2, right? In this context, radius equals to root of 2p square minus 14. Okay. Now, radius has to be less than or equal to 6. But radius is always a positive value. Most of you will forget this in the exam. Even I had forgotten this while solving initially. Hence, it took me more time. Okay. So, 0 less than or equal to 2p square minus 14 more than or equal to 6. Don't forget this lower side of the inequality. Otherwise, you will get more values of p than required. Okay. Don't forget, radius has to be more than 0, obviously. Now, on solving this inequality, the values of p we get are minus 3, minus 4, minus 5, and 3, 4, 5. Integers are required. Since we have a square value, both positive and negative values would give the same answer. Okay, hence the answer is 6. All right, it took me 4 minutes and 30 seconds to solve this equation. Should have been faster, but then as I explained to you, I made this mistake, and most of you would have made this mistake also. All right, in the exam, honestly, it is quite simple. If you just observe that we have y by x everywhere, it's a homogeneous equation, and it's just going forward in that loop. Okay, so yeah, moving on. Right, guys, our fifth question we have. Here, the equation is given in the form of a LDE, linear differential equation. So that's clear to us. But how do you find the integrating factor? Because for that, we must integrate this whole term right here to find the IF. How do you do that? It looks quite daunting at first because we have e power minus 2x plus some x square, x cube terms. So we have a polynomial multiplied by e power minus 2x. In numerator and denominator. This makes it quite tricky. But okay, hear me out. If we only had this numerator here and denominator was not there, then solving it is possible, right? So our main issue is that we have these two terms here in denominator which are causing us problems. If they were not there, solving it would be much more easier. So how do we proceed? In questions like this, okay, usually in JEE Mains, what we have to do is to convert our numerator somehow in terms of the denominator, such that terms are cancelled off and we can simplify it much better. Okay, so splitting this into two fractions would be the ideal way to go. Okay, and somehow eradicating these two weird terms in the denominator is what we want to do. Okay, so how do I do that? How do I convert our numerator in terms of these two terms? What I can do is I can remove 3x square common out in numerator. So what do I get? E power minus 2x plus 2. Okay, now all this comes from observation itself. There's no other way, because if this idea won't click to you in the exam, there's no other way of solving it. Okay, so it is a bit luck based. Those who are able to think about this on spot, solve it. Those who are trying some other method will remain stuck forever. Okay, and then so I have finished. I have used up this term and this term. What is common here in this? Okay, I can remove 2 common out. X power 3 plus 2 e power minus 2x. This is one term here in denominator, right? This is one more term in denominator, right? Therefore, we have converted our numerator in terms of the denominator, which is what we intended to do, right? This requires lots of keen observation and careful splitting. Okay, one term wrong and the whole thing is gone. But yes, this is the way to go. Divided by x power 3 plus 2, 2 plus e power minus 2x. Now, simplifying this will be far more easier. 3x squared divided by x cubed plus 2 plus 2 e power minus 2x divided by 2 plus e power minus 2x. See what we have done here? We have split it into two separate fractions. Okay, if you add these two fractions, you will get what is given here. So it's a very simple trick what JEE Mains has done. Okay, basically is this these two fractions which they have added up and given it to us in the worst possible form just to make us afraid. Okay, but if you look carefully and I don't know, pass through all the hidden layers of deceit, you will just see this staring at you. Okay, now what is the solution of this integral? We get log of x cubed plus 2 divided by 2 plus e power minus 2x. This is the solution. Integrating factor is x cubed plus 2 divided by 2 plus e power minus 2x. Okay, what is the solution? Solution is if into y is equal to integrating factor multiplied by this term. And lo and behold, what is this? This is exactly this term in denominator. So if you observe, this is what JEE Mains intended, okay, for it to cancel out. So while solving, if terms end up, cancelling or simplifying on their own in a question, you know that what you're doing is right. Okay, so we get this x cubed plus 2 dx, which is very simple. Okay, x cubed plus 2 divided by 2 plus e power minus 2x multiplied by y is equal to x power 4 by 4 plus 2x plus c. Okay, now it's given that y of 0 is equal to 3 by 2. So c is equal to 1. Now you want y of 1. Y of 1 equals 13 by 12. Yes, 13 by 12, 2 plus e power minus 2. Hence, value of alpha is equal to 13 by 12. This was actually an MCQ and this was an option there. All right. It took me 5 minutes and 30 seconds to solve. Okay, it took me quite some time. In the exam, this question was quite tricky and not spending more than 2 minutes thinking about it was the way to go. If you have exhausted 2 minutes and you're still unsure about what to do, move on, solve it later if you have time. If you got it within 2 minutes, well and good, proceed as fast as possible. All right, that was the key trick because JEE Mains wants you to be stuck here and spend 4 or 5 minutes just thinking and being stuck in a loop. Okay, if you want to beat the exam and if you want to increase your score, what you have to do is skip the question if you're unable to solve it, which most of you will be unable to solve it, and move on. That was a trick.